Negative time. Observed, can time really go backward? Time is one of the most mysterious forces in the universe. It shapes our lives, governs the cosmos, and defines the flow of reality itself. But what if the way we understand time is completely wrong? Recent discoveries in science suggest something extraordinary. Under certain conditions, time might not always move forward. It could flow backward. In this presentation, we'll explore how scientists observed this phenomenon, what it means for our understanding of the universe, and how it could redefine the way we think about reality itself. To grasp the idea of time moving backward, let's start with the arrow of time. This concept, introduced by physicist Arthur Eddington, describes time as having a direction, from past to future. This is why broken cups don't reassemble and why memories form after events, not before. But this one-way flow of time is largely dictated by the laws of thermodynamics, especially entropy, the natural tendency for systems to move from order to disorder. Yet, recent scientific breakthroughs are challenging this age-old idea. In the strange world of quantum mechanics, particles don't always behave as we expect. Scientists studying quantum systems have observed phenomena that appear to contradict the forward flow of time. One key experiment involved reversing the wave function of quantum particles. Using advanced quantum computers, researchers simulated a process that effectively reversed the state of particles, suggesting time could move backward on a microscopic scale. This isn't science fiction, it's quantum reality. In 2022, a groundbreaking study used IBM's quantum computer to test whether time reversal was possible. The team simulated the scattering of quantum particles. Imagine billiard balls rolling across a table. Normally, you'd expect them to scatter randomly, but in this experiment, scientists applied specific calculations and conditions to reverse the process, causing the particles to return to their original state. This reversal of time's flow was a controlled simulation, but it demonstrated that negative time isn't just a theoretical concept. It's observable in highly specific environments. So why is this important? For one, it challenges the way we understand cause and effect. If time can flow backward, does that mean the future can influence the past? Additionally, it raises questions about the fundamental structure of our universe. Could time be a flexible dimension rather than a fixed progression? These discoveries hint at a deeper layer of reality where the rules we take for granted might not apply. These findings don't just apply to quantum physics. In cosmology, scientists have speculated that the universe itself might experience time differently in different contexts. For example, some theories suggest that in the early moments of the Big Bang, time could have flowed both forward and backward. If true, this could explain some of the mysteries surrounding the origins of the universe, such as why the laws of physics are so finely tuned for life. Beyond physics, the concept of negative time forces us to rethink our understanding of existence. If time isn't linear, how does this affect our ideas of free will, memory, and history? On a practical level, could these discoveries one day lead to technologies that manipulate time? Imagine a future where we could reverse mistakes or prevent disasters. While this is purely speculative, it's fascinating to consider. Negative time is more than a scientific curiosity. It's a window into the profound mysteries of the universe. While we're far from mastering time itself, these discoveries remind us of how much we have yet to learn. The next time you look at a clock, consider this. What if the hands could move backward? What would it mean for you, for humanity, and for the cosmos? The possibilities are as endless and as mysterious as time itself. Thank you for joining me on this journey through time. What are your thoughts on the idea of time flowing backward? Do you think we'll ever fully understand its nature? Let us know in the comments or discuss with your friends. Until next time, stay curious about the universe